Mathematics and calculus is very beautiful and interesting the moment you realize that differential calculus does not stop in dy over dx alone. Now we already know how to find the first derivation in calculus or in differential calculus. Now what happens if we are required to differentiate over again and again and again? That will bring us to this subtopic called the higher derivative. Now we know that if y is a function of x, then the derivation of y with respect to x is going to be dy over dx. Or if we don't want to say dy over dx, we can say that dy over dx is the same thing as f at x. Or we can read this as f prime x or dy over dx. So what if we are required to differentiate the result from dy over dx or f at x over again? Now that process of finding the derivation over again and again and again is what is known as higher derivative. For example, if y is equal to 3x raised to the power of 4 plus 2x raised to the power of 3 plus 5x raised to the power of 2 plus 6. Find A. So the question on the board is, if y is a function of x, where we have that y is equal to 3x raised to the power of 4 plus 2x raised to the power of 3 plus 5x squared plus 6. Find A, the first derivative, which is known as dy over dx, the second derivative, which is known as or read as the 2y over the x squared, or it is also known as the square y over the x squared. C, the third derivatives, which is the 3y over the x cubed. And D, which is the fourth derivative. So how do we obtain the final result? This is very simple. First thing first, we have to consider the general formula for derivative. For example, let's recall that if y is a function of x raised to the power of n, then dy over dx will equal to multiply this by this, then subtract 1. So that is nx raised to the power of n minus 1. We are going to apply these principles in each of the respective terms. On the first term on the board, the derivative becomes d of dx for 3x raised to the power of 4 plus, also find the derivative for the second, which is 2d dx 2x raised to the power of 3 plus the third term d over dx, which is 5x raised to the power of 2 plus the third is d dx 6. So we are going to use the general formula, which is that on the board. So this, and this. So the result becomes dy over dx will equal to, now remember that the concept is that you multiply the power by this, then subtract 1 from the power. So that gives 4 times 3 gives 12. Then subtract 1 from the power, x raised to the power of 3 plus 3 times 2 gives 6. 6. Then subtract 1 from 3, which is 2, plus 2 times 5 gives 10. Then subtract 1 from the power, it becomes 1, plus the derivation of a constant term gives 0. So we obtain 0, which is the same as nothing. Now the final result or solution for the first derivative A is that on the board. So this is for A. Let's do the same for B. How do we determine for the second derivative on the board? The trick is very simple. We are going to differentiate the result obtained from the first derivative again. So that will become the 2y over the x squared will equal to, if you find the derivative of this term on the board, it will become 3 times 12, which gives 36. Subtract 1 from the power, x raised to the power of 2, plus 2 times 6 is 12. X raised to the power of, subtract 1, it becomes 1, plus 10x. The derivation of 10x becomes 10. And this is the final solution for B, the second derivative of the function given. Now let's consider the third derivative, which is the 3y over the x squared. To obtain the result, we are going to differentiate the result obtained from the second derivative again. So that will give the 3y over the x cubed, which equal to, the principle is that multiply the power by the coefficient, then subtract 1 from the power. So that gives 2 times 36 is 72. X, subtract 1, it becomes 1. And we omit the 1, plus the derivation of 10, the derivation of 12, x is going to give 12. So we have 12, and the derivation of a constant term is always 0. So this becomes the final solution for the third derivatives. So from C, we obtain 72x plus 12. Now, how do we obtain the result for the fourth derivative? The fourth derivation becomes the 4y over the x raised to the power of 4, which is equal to, and to obtain the final result, we are going to find the derivation of the third derivative. So that will give, if I differentiate 72x, that will give 72. So we obtain 72. And if I differentiate 12, it becomes 0, because the derivation of a constant term gives 0. And the final result is this. So in the event where you are required to determine the first derivative, you must give them the y over the x result, or f at x. Again, if you are required to determine the second derivative, you must obtain the first derivative before getting the second derivative from the result obtained in the first derivatives. Again, if you are required to determine, all what you have to do is to get your first derivative, get your second derivative, then obtain your third derivative from the second derivative. That is just the concept. Also, if you are required to determine the fourth derivative, the 4y over the x raised to the power of 4, you must obtain the first, second, and third before getting the fourth from the third one. So that is the concept in higher derivative. Now let us consider a little bit complicated higher derivative than this. Now let's consider the second question on the board. The question is, y is equal to e. raised to the power of x, and x is raised to the power of 4. Find the 3y over the x cubed. Now this question is quite interesting because we are going to be dealing with what we treated in our previous class, which is function of a function when we talked about chain rule and product rule. In this question, we are going to use both chain rule and product rule. So what should we do to obtain the 3y over the x cubed? It's very simple. The first thing we have to do is to get the first derivative, which is dy over dx. Again, we are going to differentiate dy over dx to get the 2y over the x squared. The y over dx of this exponential form, this is written in its exponential form. So whenever you see this type of question, from what we did in chain rule, I gave you the basic concept of chain rule, how to note or identify chain rules, also how we can apply the principles to get the right result. In this case, because this is chain rule and it is also an exponential form given to us, so what you are required to do is to make the group of x to become u. That is to say, this x raised to the power of 4 will become u, so that we can use the formula dy over du times du over dx. That is basically the formula for chain rule. But I'm going to introduce a very simple approach without applying the formula directly. So what is the approach? Now, whenever this type of question is given to you in exponential form, all what you have to do is to differentiate this power, the power of the exponent e. Then use the differentiation of this power to multiply with what we have here. That becomes the result. So we are going to differentiate this. And if I differentiate x raised to the power of 4, I'm going to obtain 4x raised to the power of 3. So I'm using 4x raised to the power of 3 to multiply with everything we are having here. That becomes the result. And that will be dy over dx. Now, if you are choosing the second case, where we have to apply the chain rule formula to obtain the result, dy over du times du over dx, you obtain the same result. So multiply this by what we have here. So that becomes times e raised to the power of x, which is raised to the power of 4. So the final result becomes dy over dx. Dy over dx is 4x raised to the power of 3 e raised to the power of x raised to the power of 4. That becomes the final result. Now, we have to determine the second derivative, which is the 2y over the x squared. The 2y over the x squared. And how do we obtain this result? Now, before we can determine the second derivative, which is the 2y over the x squared, we have to differentiate this term on the board again. 4x cubed raised to the power of x raised to the power of 4. We have to differentiate this with respect to product rule. So in our previous video, when we talked about product rule, I gave you the concept and a simple trick how to identify product rule. So in this question on the board, since we are having 4x raised to the power of 3, then this is first function. Another function is e raised to the power of x, which is raised to the power of 4. Now let us recall that in product rule, if y is a function of x, then we can express y as the product of u times v. U times v, where u is the first product term and v is the second product term. By comparison, if I compare what we have here, then it will become 4x raised to the power of 3 times e raised to the power of x raised to the power of 4. So in this case, u becomes 4x raised to the power of 3, and v becomes e raised to the power of x raised to the power of 4. That is the simple logic. U is equal to 4x raised to the power of 3, comma, and v is equal to e raised to the power of x, which is raised to the power of 4. So in this case, we are going to determine the derivation of u with respect to x. Likewise, as we differentiate this, which is the derivation of b with respect to x. In this function, we are having only two letters, which is u and x. So the derivation of this will become du over dx. And du over dx will give 3 times 4, which is 12. X, subtract 1 from the power, which is 2. Whereas the derivation of this function, because we are having v and x, then the derivation becomes dv over dx. dv over dx. So what will be the result? This is chain rule. Basically what we did here. The derivation of the power, then multiply the derivation of the power by the entire term. And that was exactly what we did in the first derivative, and we obtained this. So dv over dx becomes 4x raised to the power of 3 e raised to the power of x raised to the power of 4. So what is the formula for product rule? Now note that product rule, the square y over the x would equal to u dv over dx plus v du over dx. This is the general formula for product rule. That is to say, u is 4x raised to the power of 3. So the 2y over the x square is equal to 4x raised to the power of 3, then multiply by dv over dx, and that is times 4x raised to the power of 3 e raised to the power of x raised to the power of 4 plus v is given as e raised to the power of x, which is raised to the power of 4, times du over dx, and du over dx is given as 12x raised to the power of 12x raised to the power of the 2y over the x square is equal to 4 times 4 gives 16x x raised to the power of 3 times x raised to the power of 3. We add their index or power, x raised to the power of 6, then e raised to the power of x raised to the power of 4 plus 12e raised to the power of x, which is raised to the power of 4. That is the final result.